Okay, let's try another example of using a truth table to determine validity. So here we have another argument here, and we're going to try to determine whether or not this form of this argument's form is a valid or invalid form. So we're going to do the same procedure as before. So first things first, let's go ahead and create a column for each letter. As you see, now we have, instead of 2 letters, we have 3. So let's make an individual column for each one of those letters. Okay, and then let's put each premise and the conclusion on their own column here. Okay, oops, let's do this one. Okay, so we have A, or B and C, A, and then the conclusion here, we have tilde B and C. Okay. So again, now we need to use that same formula, 2 to the nth power, to determine how many rows we're going to need. So obviously now we have 3 letters, so it's going to be 2 to the 3rd power, meaning we're going to have 8 rows this time. Okay, and so this is why I was saying earlier that it's important to be as neat as you possibly can be when constructing your own truth tables, because you know these things, you start adding more and more rows to them, and things can get very cluttered. So you need to be careful in how you're laying out your truth table. Okay, so now we know that there are going to be 8 rows. Okay. So in order to determine the number of trues and falses in each, the way the pattern works for each column, we need to take 8 and divide that by 2, which will get us 4. So we know then that in the column for letter A, we're going to have a pattern of 4 trues and 4 falses. Okay, for B then we're going to take 4, divide that by 2, and so now we know that each individual truth value will come in pairs basically. So we're going to say true, true, false, false, true, true, false, false. Okay? And because C is our final column, we know then that we're going to just alternate true, false, false. And again, that matches up with 2 divided by 2. So then we have true, false, true, false, true, false, true, false. So these are all the possible truth values that can be combined in this argument. All right, so let's start with the easy column first. A. The second premise is just by itself, so basically we can just copy this column and put it into the column for the second premise here. So true, true, and again be very careful as you're make sure you're trying to line this all up. It is difficult, but it's necessary in order so that you can read the table correctly. It's a little bit there, but right. All right, if it helps, just make a grid of it so that you know which one is hooked up with which one. Okay, but now we have more complicated situations here with the first premise and the conclusion. So let's just look at our first premise here. So again, as we did with the truth function calculations, we need to figure out for this particular premise what the main operator is, the operator that has the widest range. Well, because of the parentheses, we know then that the ampersand's range only includes B and C. Okay, so we know that is not going to be the operator it's not going to be the main operator, it's not going to have the widest range, so we know that this is going to be the first operator we ought to work on. The final operator then will be, of course, the wedge, okay, which is our final column. And again, as I said in the last video, I think it's a good idea to try to make sure to mark off for your own purposes that this wedge is the column here that's going to give you the final value for this whole premise. Okay? So let's just go ahead and plug in the relevant truth values here. So again, plug in all the truth values for A. Okay? And I think it's important to show your work just so you make sure you don't make any mistakes. I know it can make things look really cramped, but again, this is to help you make sure you don't get off track on a specific row. Plug in all the values for B here. And then all the values for C. All right. Okay, so we know then, as we've already talked about, that the ampersand is going to be the first operator we're going to work on. So all you got to do is just go down the line here. So if we have true and true, that's going to get us true, okay? And then we know that with conjunctions, the only time the entire conjunction is true is if both conjuncts are true. So we can see here that this one's going to be false, false, false. We have a true again, false, false, and false, okay? So this column here, the one that we just did, is going to give us the final value of this whole chunk right here of B and C. So we're going to use that value and then combine it with the value via the disjunction here with the A column. Okay, so in order to determine what the final values are going to be here in the wedge column, you need to take true in the A column and then this true here for the whole entire under the ampersand. And so true or true, we know from the disjunction operation table, is true, true here, false here, true, true, false, is true, true, false, again is true, false, true, still is true on a disjunction. And now here, false and false, this, again, going back to the disjunction operator table, we know that's the only time in which the whole entire disjunction is false. False, false again, false, 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 false again. And there in that little boxed off column is the final value for this first premise. So let's go over here to the conclusion and do the same exact thing. So let's determine what our main operator is. Well, we can see that the ampersand only has the range of the B and the C, so that's going to be that's not the one with the widest range. So that's going to be our first operator we're going to work on. And then the tilde here has the whole, it is basically negating the entire conjunction. So this one is going to be our last operator we're going to work on, and it is our main operator. Okay. So once again, let's just go ahead. So first of all, let's just block off the tilde column to tell us that this column here is going to give us the final value for the statement, the concluding statement. Okay. So let's go ahead and plug in our values here for B and C, just B and C as they are. Okay. And so let's start again. First operator is the ampersand, so let's just go down the line here. True and true is true, true false is false, false true is false, false false is false, true true is true, true false is false, false true is false, and false false is false. Okay, so this one's pretty easy when you have that tilde as your main operator, because all you're going to do is you're going to negate the values underneath the ampersand. So the opposite of true is false, true, 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 false, true, true, and true. Okay, so we filled out the entire table. Now let's use the table to determine validity. Now again, we are looking for, so the way that all truth tables work here is that if you can find a case where each premise is true and the conclusion is false, then you can say this whole thing is an invalid argument. But if you can't find that, then the whole argument is valid. Okay? So let's just look here. So again, we want to look at this column for our final values and this column for our final values for the conclusion. All right. So again, the easiest way to do this is to look at your conclusion column and figure out and look only at the rows in which the conclusion is false. So in row 1, the conclusion is false. Let's see here. So false, okay, but this premise is true, and then this premise is true. So right away we can see we have two true premises and a false conclusion. So we can see right there that immediately this argument is going to be invalid. Okay, so let's just check and see if the other case in which the conclusion is false also renders an invalid row. Okay? Well, in this case, the only other case in which the conclusion is false is here on row 5. And we can see then that the premise, the value for A on this row is false. So immediately we can see that the problem isn't on this row, but it is on the first row. So because there is one row, at least one row in which all the premises are true and the conclusion is false, we can say then that this whole argument is invalid. And more specifically, it's invalid by row number 1.